Hey guys, this next tutorial will be on classes. Okay, so I did show you back in my past videos about structs, a lot of stuff about structs. Structs, they are useful in programming, but in reality, they're not as flexible as classes. Classes are related to structs, okay, but they can do a little bit more than structs can. Let me show you one example where you'd use a class and it'd be a lot more helpful to use it as opposed to a struct. First of all, classes can make an instance, or it can assign a value to a member type inside of its class right off the bat. So right when you create it, okay. Before we get into that, let's say we had a struct. Let's just do animal, and the animal had int weight char. I guess we can do type. So say it had a weight and a type. Off the bat, if we wanted to output the weight and the type of any animal, okay, so we can create an animal in our main function. So if we wanted to create an animal, we'd simply do struct animal dog, okay? If we wanted to output the weight and type of the dog, okay, so I guess it's a mammal and it's whatever, 40 pounds. Let's see what we'd get. So we'd use dog.weight and we'll add a space and then dog.type. I'm kind of curious what this would output. So as you can see, it outputs a lot of garbage, okay? It does not output the correct stuff, okay? What it does output is whatever's stored in our memory. So I guess this is probably an address of something else and a bunch of crap that really has no relevance to what we're doing, okay? This just shows you that there's nothing giving that dog's weight a value, nothing giving that dog's type a value, okay? With classes, there's something called a constructor, okay? So what happens when you have a constructor is whenever you instantiate a struct type, such as animal, and you give it members, we have an integer in this case and a char in this case, the constructor assigns values, default values, to the char type and the int weight. And you might ask, why would you need a default value? Why can't I just add whatever value I want to? And that's a very good question, because say we wanted to work with the weight of something else. So say we had struct animal cat, right? And assume that we want to take input for the cat. Okay, so we wanted to take input, and we didn't want to do this. We didn't want to do cat dot input is equal to 0. Okay, or weight. Sorry about that. Cat dot weight is equal to 0. We don't want to do that because it's a waste of time. Okay, it's a waste of time. We don't want to do that for every single animal that we have. Say we have 10,000 animals. We don't want to do that for 10,000 animals. We'd have to do that if we were to take input. Okay, because sometimes when you're taking input into variables that don't have an initiated value of 0, such as just like int x, right? Okay, if you just had int x, for example, and you did not do int x is equal to 0, so you did not do that, you just did int x. If you wanted to work with this variable right here, it's much less safer to do that because you're not giving it a starting value. Okay, you're assuming that the compiler is going to give it a starting value, but it doesn't work necessarily all the time. Okay, sometimes if you don't simply do int x is equal to 0 and you just do int x, you can run into a lot of problems. Okay, if you try to output int x, or you try to output x right now, you would not get a safe number. Let's just do it right now. Let's just output int x. Okay, try to output that, and we'll go into our Okay, do we get 0? Do we get 0 in this case? No, we don't get 0. Okay, we get some garbage, which is in our compiler, which is stored in our memory. Okay, so it grabs whatever it can from the memory and it's going to say, okay, I'm going to throw that out to the user. If we do this, int x equals 0, and then we output that, we get 0. Let's try it with the structure. Let's output dog.weight without giving it a starting value. So all we're doing is we're creating weight and type inside of animal, and we're creating an instance of the struct called dog. We're not giving a default value for weight, not giving a default value for type. So we'll go back and we will compile this, and what do we get? We don't get what we want to get. We get some weird number, okay? We're expecting 0, okay, because we think, okay, when you create a variable, it'll be set to 0, or if we create a char, it'll be set to null. But that's not always the case. It's never the case, actually. With structures, it's less easier to really instantiate proper values types, okay? With a class, it's much easier, okay? There's something called a constructor in classes, which I just mentioned before. Okay, constructors, what they do is they can assign default values to our member types. So dog will have a default value 0 through our structure, or sorry, through our constructor. So we have weight and we have type. To create a constructor, it's simply just like any other function. We simply use animal, in this case, whatever the type is, bracket, bracket, and a semicolon. Okay. What this states is that we're going to instantiate default values for the weight and the type. Might want to make this public, because another thing with classes is any value in a class, the default value, okay, any value between this parentheses and this one over here will be private. With structures, it's the exact opposite. Structures will have everything public, and then unless you specify that it's private. So if you wanted to make animal private, we can't have constructors in structures, but I'm just showing an example here. If we have private after the fact, everything after private and before this will be private, okay, privately accessed. So we can't access it from the main function anywhere outside the scope of the structure. But in this case, we want to make the constructor public, okay? And this constructor is called automatically. So after we have this stated, just like in a structure, you'd have to create what's in this function. For a constructor, you have to do the same thing. The computer does create a default constructor for you, but you have to instantiate it. You have to put it out there, okay? So it's basically the actual name of the class. So we'll just copy that. And in this case, it could be public. It doesn't really matter. So after that, we can use the scope resolution, which is the 2 semicolons, or the 2 colons, and then we will reiterate the name again. So animal, and then 2 brackets, because we're not sending anything. It's already aware of these 2 member types. And then after that, we have to actually code the constructor ourselves. So it's simply animal, animal, and inside here we can assign the default values that for weight and the default value for type. Let's make weight equal to 0, and we can make the type, we don't need this, just type is equal to blank. And we can actually output whatever we want here. So okay, so we have class animal, and then we'll have to do whatever animal it is, so dog, and we can output dog dot weight. So I fixed a couple things up. Class actually has to be not capitalized. Class is just like that. And when we give an initial value for type, we have to refer to the first value type, the first array in the string. Okay, so type at 0 is equal to null. So we're referring to one character as opposed to the entire string. After that, we simply just make the animal dog, and then we just output the dog weight. So I have it here already, and we have 0. Okay. If this was a structure, we wouldn't have 0. We would have a bunch of crappy numbers. Okay. We'd have something that looks like that. Okay. We don't want that. We want this. Okay. When we want to input data, we're inputting it into a safe value. This right here is as safe as you can get. You can't get any safer than this. Okay. If this was a structure, you'd have this and you'd have this. Okay. Now, if we didn't state that we want weight is equal to 0 and we want type at 0 is equal to null, we can simply make it blank. And what the compiler will do is it'll see this and it'll create the default values for you.